Yeah, I'm Ben Adam Smith from House Planning Help, and this is going to be an exciting one today because obviously we know Mike and we know a little bit about what he's been up to, but now he's going to share that and the rest of the team are here as well. So I think from my inside perspective at the moment, there are a few elements of this that are quite exciting, growing out of a pain point and thinking how can we deliver these fantastic, sustainable, high performance buildings. Then all the determination that you need as a startup to get this off the ground is another key thing. And then I just have such respect for their ambition, as I'm sure we're going to hear, that they could set the bar a little bit lower, but they're trying to do it all. So I'm going to hand you over to Hugh. What do you think?
Yeah, so thanks, Ben. My name is Hugh Wiersky, Director and Founder at Partel. And I guess, like Ben, I've been following the Kiss House story and Mike for years. And I suppose I can say it's one of the projects that I really, really want to see succeed. I suppose people tend in startups to have maybe get distracted by fitting in with what's happening in an existing way. So I don't think that's what's happening here. So they're absolutely true to Passive House, and I suppose the impact on I suppose on the environment. So yeah, extremely interested to see where things are right now, and maybe to get the message out there for Kiss House. So Mike, over to you.
Yeah, thanks, Ben, Hugh, Zach, and everybody. So with my co-host hat on, this is the last episode of the BPI. It's been a really interesting series, and it was great to be asked to be part of it. And it's a little bit unusual to be introducing myself. So the less said, the better. I think I'm here with my colleagues, Carli to my left, and Richard to my right, and Max, who's on another little box on the screen. And yeah, we're gonna lift the lid a little bit on what we've been up to. Ever since I came into the industry about 20 years ago, I've always thought there must be a better way. I was kind of horrified to begin with by the culture of cover everything up, people will never know, corner cutting, cost cutting, that general sense of the construction industry being undervalued as well in the UK. From the very beginnings, I kind of thought, this doesn't feel right. And so over a period of time, I gradually got more and more interested in trying to find out what that better way was, what it really meant to deliver better buildings that did feel right, and it felt right to work on, and that felt right for people to live in. And it really has been quite a long road to get to where we are today, delivering a variety of really challenging, really complex projects. But on every one, it's brought us a step closer to what Kiss House is now, which is essentially a vehicle to try and transfer all of the lessons learned over that period of time into something to benefit a wider audience, to benefit more people from repeating lessons learned that otherwise were getting trapped on complex, bespoke projects.
Kiss House, it's a series of really interesting challenges that make me want to get out of bed in the morning. How do we create something worthwhile? How do we create homes that make people feel that they're a joy to live in? How do we deliver them in a way that is different and better? And these are all easy things to say, but very hard things to do and achieve. How do we live up to our ideals, for example, of building houses that use natural materials wherever possible, houses that we don't use wet trades in, for example, and the interiors are really hard wearing and easy to maintain and long lasting and look beautiful.
Over this initial startup phase, we realised that we were solving problems to make our own housing product better that had a wider application. And as soon as we saw that, we realised the business model was completely different. We've evolved into a construction product innovation business. We have a range of houses, Kiss House, passive houses at the core, as the core product offering, and then we're commercialising product systems and materials with a wider application that other people can use in their houses and taking those to market.
Our business model has changed and we've become an innovation hub. The pandemic caused our planning applications to grind to a halt, so we focused on developing more of the ideas that we'd had pre-COVID. These were all focused on problems that we'd identified, and they all shared this single ambition of finding a better way. It's been both exciting and challenging in equal measure, as it has forced us to get comfortable with change and has meant that when we've identified a better way of doing something, we've had to be prepared to rip up the rule book so that we can do it differently. The driver ultimately has always been achieving an optimal balance between design, performance and delivery. Identifying a problem and then seeking to solve that problem by designing out the complexity and building in everything that matters to us. An example of this is the problem of building an extremely smart, low-carbon home and then doing the foundations the way they've always been done. In other words, digging an enormous hole in the ground and filling it with concrete and steel, which then massively ramps up the embodied carbon again. Our solution has been to create a passive house compliant ground floor system, which virtually eliminates concrete and steel and which can be used on the vast majority of sites. We now have a patent pending for this.
We've always been involved in passive house projects in the UK since the beginning, since before there were any. And it's really the only objective, measurable standard that's had widespread uptake. So a best practice standard for energy performance and comfort that is clearly defined, rigorously assessed, and has had an uptake all around the world. So is seen as the gold standard internationally for best practice energy efficiency in construction. And so for Kiss House to adopt that standard, it's really the only way that we can point to something that is widely known and understood as a measure of quality. But it also means that we, every step of the way, have to carefully audit and monitor and control everything that we do to ensure that every one of our houses not only complies with that standard, but will guarantee comfort and performance over time for everyone who lives in a Kiss House.
A huge piece of R&D we've undertaken has been work that aims to simplify the delivery of passive house homes at scale. Passive house is site-specific, but we wanted to create a product and to not have to reinvent the wheel for every project. We wanted our product to enable architectural flexibility and for it to be capable of delivering both Kiss House homes and other housing typologies. We had a plethora of goals within this project. For example, we wanted it to be passive house compliant without having to redesign the wall build-up and undertake extensive site-specific engineering for every site. We wanted it to be made of wood, but not reliant on engineered timber because this faces supply pressures. We wanted it to be a beautifully resolved kit of parts that would give us the architectural flexibility to offer customization to our customers. We wanted it to be precision engineered in controlled conditions so that we could guarantee not only quality but also an optimal working environment for operatives. And we also wanted our product to be hand finished on site to guarantee quality of finish. We wanted to eliminate wet trades and scaffolding on site to dramatically reduce site disruption by reducing journeys to and from site, time taken on site, and all of the noise and air pollution that's generated, and so on. The work to achieve all of this has been immense. It has led to the creation of our low-rise residential construction system, which achieves all of the above and which in turn has meant we've also innovated and enhanced natural fibre insulation, which we've now trialled at Bangor University and which has a patent pending. This in turn aids the systemisation of our offer because we can maintain the same wall build-up across sites.
We are now able to deliver numerous housing typologies, really flexible architecture within a series of rule sets that enables us to deliver really high quality passive house homes at volume.
What's really exciting about all of this is that it has led to us fulfilling a major early ambition, that ambition being to open a centre of manufacturing excellence. We've been prototyping with our manufacturing partner for a while, and now we've all taken the decision to join forces. This means we now have the manufacturing centre of excellence that we aspired to, and more importantly, we can deliver a vertically integrated solution, or if you like, an end-to-end offer under one roof. And now we're building a show home here.
We try and minimise the amount of drawings that we have to do. If we can input the data direct from the model into the machines, there is no human impact on that, so you don't get your errors. Whereas when you do drawings, one, we can't load drawings into the machines, and two, it's got a human input. Whereas with the digital file, it's automatically loaded in there. And if you change the length of that bit of timber in the file, the data changes with it, so your next bit of information is also accurate. We put the data in, the costing data into that model, so that when they're happy with their finished product, we print out a list that has got all of the components that we need on it, all the sizes, plus the cost data in there. We're working with the architects so that we can then put manufacturing times to those components, so that it gives the client a more complete budget initial cost for their house. We will take all of the data out of the model, put it onto a memory stick that's relevant to the machines that the operatives are working on, and hand over that memory stick for their day. They then take that data into the machine and make sure that all the material's going through, and then they're stacking it in the correct assembly module. So the material that's getting kicked out of the machine, we assemble into items called assemblies that are relevant for each cassette, and then those assemblies go to an assembly table. The link between the manufacturing and the assemblies helps by the digital model, because we can do print screens so that you have a visual representation of what your finished product needs to look like. You've got your accurate parts that match the model, and we've created rigs that are laser cut and laser welded together, so we know that they're accurate. All we're doing is taking the parts, assembling them on the table, and taking them off at the other end, so you get your high quality, high accuracy product. On the latest Kiss House development, all of the linear cuts for timber, we managed to reach 98.5% efficiency for the linear cuts, so the wastage on that is very, very small. We're trying to go one step further. It's in early stages at the minute, where we're loading the weld paths. We've got a robotic welder, and we're trying to load the weld paths into the actual components. So again, once you've got your house, you can take your components out of it, load the files into our welding robot, and it will create your part exactly the same every single time. So all of your welding parameters will be the same. So from a Q&A point of view, you can go into mass production quite easily, knowing that all of your parts have been welded the exact same.
If you take the car manufacturers, for instance, you don't see a car coming down a production line and like parts being cut and made to fit a car. So we kind of take some sort of influence from the manufacturers in the sense of we wouldn't send a pack of plasterboard or bulk material to a project and then cut it on site and then throw the waste in the bin. So for us, that's like a big driving factor. It influences our design and our principles moving forward as a venture. So Kiss House predominantly is a kit of parts that has been designed to come together to design a well-defined set of disciplines and interfaces that construct the house. So one of the big things for us is reducing the negative impact of the embodied carbon in construction and then the built environment. And by reducing the amount of material of wastage at the factory gate, it reduces the negative impact to the house has on the built environment. We don't lose all the productive routines and the efficiencies we build in the factory as soon as it leaves the factory gate. So we try to carry that on by influencing how the system comes together. It has its own temporary work system to assist with construction of the house, and also its edge protection system. So health and safety is quite a big thing for the team. We want to make sure that the houses are delivered and constructed in the right way, but also safely.
Hopefully we've provided a flavour of what Project Kiss House has been all about over the last few years, and the work that we've been doing to challenge design, performance and delivery to enable the creation of high quality passive house homes at scale. Of course, the pursuit of excellence means that the work is never ending. So as we move forward and deliver live projects, we're focusing on feedback loops and improving as we go.
Wow. Fantastic. So Max, I think you're up next.
Sure, hello. I'll just share my screen. Okay, so I'm just going to talk a little bit more about the detail of, you saw in that video, various panelized components flying together to form houses. I just want to talk a little bit more about how those various components fit together, how we handle the junctions, why we chose a panelized approach, because there is a bit of an inherent tension between lots of bits, lots of interfaces and passive. So what you're looking at on the screen is a sort of performance version of the model. It doesn't have any cladding, rain screen, etc., or glazing. And it's worth mentioning there are some internal load varying features that don't add anything to the performance envelope. And actually, we've chosen to construct them initially in a more traditional approach than a not modular, due to the constraints of the building process. When there's obviously quite a big jump to go from that to this, and there's loads of ways all these panels go together. So when we came to start the project, we thought that it would be better to have a catalogue of repeatable details where all these different components come together, and focus on the design of those details, and let the cassettes, the elements between those details, change in size, because it was evident that architectural flexibility was going to be really, really key. So these are sort of Lego brick sort of images where we initially defined all the different junctions we were going to try and incorporate, and it also defined the form of the cassettes to know which cassette was doing what in terms of the building envelope. We have so these two top ones are plan images. We've got the wall cassettes in orange. Wall cassettes have no structural use at all. They're entirely performance based. And then integrated into those, we have the structural elements and glazing elements. And we chose again to exclude sort of, we didn't want to make a window cassette part of the performance envelope of the building, so we felt it was blurring the lines between what the cassettes were supposed to do. In elevation, we've more or less done the same thing. So we've got wall cassettes, window cassettes, and our roof cassettes. And again, the structural elements of the horizontal cassettes integrate into the wall cassettes, but again, they always wrap around and envelop the structure. So with lots of architectural flexibility, how do you enable these details to be repeatable across loads of different house types? This is obviously a relatively small portion, but it begins to give you an idea of the kind of differences we're going to have to deal with at the cassette level. So in order to retain the integrity of the details, we devised a system of panels, both horizontal and vertical, and variable pitching for the roofs. And those panels are better thought of as a collection of rules, a sort of theoretical design that is realized in many different ways. So, for example, in a timber floor cassette, the perimeter details running around the edge of these cassettes is entirely consistent build to build. So that element integrates into the wall cassette, that retains its form, and it retains the fixing methods to the spanning elements. They're the same in every build, so the design doesn't change. But however, the length and width does change of that cassette. So what you end up with is a flexible component that retains its design intent across a range of sizes. And we developed structural strategies that enable, so for example, if this length was 0 to 5 meters, we use strategy A. If it goes up to 10 meters, we do strategy A plus B. So the structure evolves as the panels change in size, but it evolves in fixed increments. It doesn't, we're not constantly redesigning structure. So we have an entire panel and component family designed with this method in mind. So we've got horizontal floor cassettes, We've got shear walls. The structural strategy relies on is a shear wall strategy, and we've got glazing cassettes again that flex in size and height to ensure that the chosen window products can fit in. And we've got roof cassettes that enable a variable pitch. They go all the way down to a sort of minimum pitch, and then they jump to flat to achieve flat roof typologies. So if we jump back to the model, I want to talk a little bit about once you've put all these cassettes together on site. Well, actually, I'd also like to just say additionally why we chose to go with this panelized approach, because it gives you lots of connections. We just felt that panelized approach, although it does give you site work, which a full modular volumetric wouldn't, as mentioned in the video, the company are always quite happy with the idea of site work, although they wanted to restrict it to certain processes, eliminating more messy processes, but ensuring that you retained a sort of high quality on-site finalization. The small size of the cassettes is obviously much better for transportation. You're not shipping large boxes of air. It's better for storage if you wanted to make them a little bit in advance of projects. And it's obviously better for movement on site. You don't need the kind of enormous mobile cranes that some of the modular ones approach. Also, if you are setting up a factory, the scale is beneficial. You're looking at workbenches and small warehouse style forklifts, as opposed to large buildings and overhead gantry cranes and stuff. So when the cassettes come together to form the house, we obviously have lots of horizontal and vertical joints to deal with in the finished house. The way we've chosen to seal these cassettes, which is obviously really important to maintaining the integrity of the passive house, is we have our consistent joints that we've dealt with before, and we have a uniform strategy of filling and sealing those joints on site. On the outside, on where we have a split line, we fill the cavity entirely with a compressible insulation material. So when the cassettes come, those are pre-adhered to the joints in the cassettes. So when the cassettes come together, they create a naturally insulated seal. On the inside and outside, there are compressible seals that remain flexible throughout the life of the building. They're dry applied and they remain flexible throughout the life of the building, which means that any structural movement over time is dealt with. On the outside, operatives will tape and seal joints, and we've got a small stitch plate to make sure that the wall cassettes don't start moving relative to each other. And on the inside, we've got all this lurid purple is pre-applied liquid applied membrane. So the majority of the panels are coated in the factory, and the split lines are left on site, and an operative with a paintbrush and a tub of fiber enhanced sealant runs around and paints all the joints. It's visually very, very simple to see where it needs to be filled and where it doesn't. It's flexible over time. Also, it means that it's very easy to repair on site. And it's worth mentioning, you see the battens up here. This is not the finished site. There's actually another 50 mil of what we call service zone on the inside of the cassettes, which means that when occupiers hang pictures or something like that, they're not penetrating the BCL, so the BCL remains integral over time. And that's how we go together to build the KISS house. So that's the end of my rather rushed technical presentation, and I'd just like to hand back to Mike when you're ready.
Thank you very much, Max. Very grateful to you for running through that so thoughtfully and carefully. I'd just like to draw everyone's attention to the QR codes. We've created a short ebook to accompany this episode today, if anyone would like to scan that, and then we'll be following up later with another more comprehensive ebook, and including a link to the video and so on from this episode. It's just really it's really lovely to be able to sit here today talking about the journey that we've been on, but I wish to highlight that we are still on that journey. This is a long, hard journey. In many ways, it feels like we're at the start of it again, because we're coming together with our manufacturing partner. We're about to build the demonstration house. So whilst we're talking about what we've been doing for the last few years, We are well aware we've got a lot left to do, a lot in front of us, many more challenges to overcome. But this is what we get out of bed for. So it's been a pleasure to introduce this to everybody today. I don't know whether I'm wearing the co-host hat or the Kiss House hat right now. So I'll hand over to Ben and see what he's got to say.
Well, I want to commend you, first of all, because I know how much work has gone into this. And I think just looking at your presentation, you can see it. And I can't wait for you to get that physical manifestation of all this hard work that I'm sure you will then be refining. So I just wanted to underline one thing, which was that line about the balance between design, performance, and delivery, that I think so many people want this. So if you crack this, we know it's going to be highly desirable. And I suppose one aspect that I'm wanting to know a little bit more about is really the boundaries for the client. If you're coming in fresh and wanting to use this, as I say, I think we all get why we want to go this way, and the fact that you've encompassed so much within your delivery and your product. So that side people will get, but is there any way they can mess it up as such? Is that a question that makes sense?
I think it does make sense. And I think boundaries is a really good word. So the idea is that there is inbuilt flexibility, there's architectural flexibility, and there's the ability to customize the home, but there are boundaries. There are kind of parameters within which that works and that doesn't work, if that makes sense. So for example, the system works on a set of rule sets, and those rule sets are both structural and drive the manufacturing and construction. But in terms of Kiss House as an actual housing product, there are other boundaries, because it is governed by an aesthetic appearance as well. So I think that's quite an interesting point, because that's where the system allows us to do something quite different with the business, because it allows us to produce Kiss House homes, which are governed by all of those things. And then also we are able now to use our system to produce housing typologies, again within the rule sets, but other housing typologies for other people. Does that answer your question?
Yeah, no, I think it does. And I'm sure all of this development time as well, are you, might be asking a silly question here, but really eager just to get this first build done? Is that the stage you're at now? I sense it, perhaps.
Yeah, I mean, yes, exactly. So we have 5 houses in the late stages of planning. COVID hit that really hard and has caused horrid delays at local authorities in the UK. And then we have another 6 houses with an outline consent. So yeah, in fact, we're at the Reading local authority this afternoon, and we've been told that we will get this consent for those 2 houses. There's just an affordability levy issue to iron out. So today could be the day.
Hugh, what are your thoughts? Hugh, have you got your mic on? Is he there?
Yeah, should be good now. Thanks, Ben. So yeah, thanks. I guess, Mike, I've been thinking back about when I met you first. It was on a passive house project, and I suppose I was struck then at the time about your ethical approach, and that really came through a lot at the time, but also the frustration, kind of honestly. And yeah, we're dealing with kind of dragging a lot of people along with you to get to where you wanted them. And I suppose one thing that's obvious is you're not frustrated now, which is great. You've got people going in the same direction as you. That's lovely. But I suppose kind of look, obviously well done on developing what you've developed so far and maintaining and, you know, building on that ethical approach towards building, and I would say probably towards working with your clients by the sound of things. But another time I met you, I think it was just after Lloyd Alter had featured you in Kiss House, and I remember that at the time as well. You were you can either thank or say something different to Lloyd today. I think he's here, but I think your workload went up that day. So probably you lost a few hours, but I think what that really struck at the time was, and I was at the same, I thought the idea of what you wanted to do sounds amazing, still does, and it's really good to see those details being worked through. So I have two kind of questions that I'm wondering, I guess. You've resisted, it would seem, the urge throughout this process to, I suppose, maybe that everyone else is affected by, and that's I suppose, the urge for profit and scale, which everyone kind of seems to go that way towards before working out all the details, and people tend to make the mistakes and iron out things afterwards. And that's one question that it's definitely an unusual approach. It's terrific, obviously, but I'd like to know kind of how you managed it. And afterwards, then, about scale, like Ben said, if you crack it and you get the system right, there's going to be lots of people really interested in it. And I know you've had interest from all over. Do you have plans in place that you could license this technology, and maybe other factories can skip a lot of those, let's say, awkward steps where they can make those steps? That's so. Two questions at the end of all that. I hope they came out.
Yeah, what was the first question, Hugh?
Yeah, so how did you resist the urge to build houses quickly and make money?
Yeah, I think when we started this, and I'll come to the Lloyd point in a minute, when we started this journey, it was not, we were very, very busy doing other things. This was not necessarily on our radar. So when the opportunity arose and we looked long and hard at it and thought, well, hang on, there's something here that is demanding our attention, we made a commitment that we were only going to do it if we did it properly. Otherwise, we weren't going to bother doing it at all. And that was the starting point. That was the starting point. We needed to bring with us the right sort of committed long-term patient investors who were going to support us on the journey, and we were not going to cut any corners. Now, that's not about being idealistic, purist, navel-gazing. It's about being careful and committed to something that we believe is right. We were not motivated by all of the things that were compelling, overwhelming reasons to start a business 3 or 4 years ago, namely, the statistics to do with the so-called housing crisis, the bandwagon, and all of the noise related to off-site modular. All of that stuff felt to us like a little bit of a distraction, and maybe perhaps even a bubble waiting to burst. We've been focused on trying to build some really great houses, learning from drawing from all the lessons that we've learned over many years. And we believe actually there is a scalable business here. It's probably just going to take us longer to get there than it would if we'd been motivated primarily by profit, and if we'd had aggressive, impatient investors, expecting a very rapid exit. Richard probably got something to add in terms of the scale potential, because we do have a highly scalable model.
Yeah, I always find the scale question an interesting one, because how do you judge scale? In that you can create a factory, put a lot of money into it, and create 100 houses a year. Those houses may not be any good when they get out of the factory, but that factory will be judged on that scalability. For me, building 10 really high quality houses that are coming out of the end of your factory is a lot better than 100. And I think the way we're judging ourselves is different to others. In we won't get to the end of a year and say, you've only built 11 of these houses, we wanted 100. We don't see the need in building 100 houses that when they get to site, there's a lot more work to be done on them. The clients aren't happy with them, and the design aren't as well thought through. We've been lucky enough to work with Max for a long time. We know the effort he puts into design, and we want to put, we think it'd be a shame if we take all that effort and just sling it together. We think the effort actually deserves some thought at the making stage as well. And he's smiling about that, so that's a good thing.
Yeah, I think if we take our time on getting these things right before we rush into scale, then the scale will follow, and it will follow in the right way without problems and destroying our reputation by putting out something out that we just wouldn't be comfortable to do.
The model is scalable, the manufacturing is scalable, but it needs to be done in the right manner.
on the Lloyd point, I think we, because I can see him now, we will be forever grateful to Lloyd for his early interest and support. We don't know whether we should have said it's too early for us to do an interview with you, Lloyd. Maybe we shouldn't have done, but on the other hand, what it told us was that we were onto something, even if it was too early. And so people everywhere expressed an interest in what we were talking about and what we were setting out to achieve. And it gave us a lot of confidence and motivation to keep going. So that's, yes, it did spike inquiries when we were unable to fulfill them, but it gave us motivation to keep going as well.
Lloyd has a habit of doing that, doesn't he? But yeah, congratulations once again. And I know there are lots of questions, so I'm going to hand over to Zach now to sift through them.
Yeah, great. Thank you. There are a lot of questions. So the first, so I did not type in these names, so this may be a surprise, but the first one up is Paul Scholey or Scully. You had a couple of questions. Let's see if Paul is still here.
Hi. Yeah. No.
Yep.
It's interesting. The use of a steel beam foundation base with a screw was quite interesting. How do you cover the interface between the steel and the base cassette, particularly with regards to thermal bridging as a passive unit?
It's not a steel cassette. It's a different material, and there is no thermal bridging. But there are screw piles. It's just that the cassettes themselves are formed out of a composite material, which has got very low conductivity.
Right. Okay. And my second question was: is the intention for the build to always be timber, or are there other build materials that lend themselves to the KISS principle?
Yeah, I think it's a valid question. For now, we're committed to timber. I think there's scope for us to explore other materials for the internal finishes and external finishes, but as a structural system, on the basis that it is a renewable resource that we're able to process in-house and machine to high levels of accuracy, we feel it's the most appropriate material for us to use for our structures.
Okay, thank you. Thanks very much.
Excellent. Thank you, Paul. Thanks, Mike. So next up is Darren Jones.
Hello there. Hi. Really impressive setup and really impressive design. My questions that I did put in the chat were actually all about the kind of how much you've delivered and what the scalability is, and you've kind of answered those already. So I'm going to jump in with another question that intrigues me, which is I really love the aesthetic that you've gone for, and I'm wondering kind of where that came from, and if that is part of the appeal, because I think there are a number of other organisations in a similar kind of space to you that are looking at kind of much more traditional housing. And are you finding that people kind of there is a really strong appetite for this?
I think we are finding that. Yes, I think we're finding that it's different, it's distinctive, let's say. And I think in terms of where it's come from, I think it emerged over time, and I think it's still developing. We're doing an amazing piece of interior design work at the moment, because we've given ourselves this problem of not icing the cake by using plaster. And so then it's, well, what do you do then? And but it's really exciting, because with all of these things that we want to do differently, so comes another challenge. And yeah, it's really interesting. I think at the end of the day, the house, the form is quite simple in most cases, although with the system we can do split forms and different things now, but ultimately the form is quite simple. So I think we've always felt that perhaps it will be the interiors in some ways that we become best known for. Yeah, ongoing. So thank you.
Great, thank you.
Great, thank you, Darren. Next up is Liam Newton.
Oh, hi, is my microphone working?
Yes, sounds good.
Oh, hi. Yeah, I had a couple of questions actually. One was about sort of cost per square meter. We're in the northeast of England, and I've found that there's a sort of tipping point at which point the cost per square meter, and you end up with a house costing more to build than it's worth. And I just wondered how you do that in areas that are sort of more marginal than, say, places with a very high house value.
Yeah, hi Liam. Yeah, so it's something we look at really closely. The final cost, a lot of it is influenced by the finishes you have. So obviously, if you go for a high cost cladding on the outside and inside, your cost per meter square is going to be a lot more. You can bring that cost down by using cheaper materials. We don't tend to do that. We don't like doing that. So what we've looked at, we're basing it on a lot of studies from the council, what they like to spend on their social housing. We've taken that value, and our specification is actually higher than what the councils will build. We've kept it on just used the system as a cost, and we're looking at around 2/3 at the minute of the cost of what the councils will spend on their social housing. So that's not done through cheaper materials. It's not done from cutting corners. We're actually looking at how we can assemble it better with the architects. So cutting down the program on site, which, as you know, is a huge cost. We're looking at it through the design itself. You need less people at the start, so fewer input from the structural engineers because it's all being worked out from Max's designs, and also architecturally as well. Like Carli said earlier, sticking within the boundaries, there's less cost on the design work. So right at the start, we're already ahead from a cost point of view. And then we're taking that through the manufacturing too. So obviously on site, when you work out the efficiencies of when you're working on site, you're quite low efficient working there. Whereas we're keeping it in a factory setting where we can keep the efficiencies quite high. We can monitor how long it takes to build each wall cassette. And if we want to bring the costs down, we're not looking at what material we can cut back on. We're looking at how we can make it better. So that might be an investment in a new machine. It might be just switching the way we do things inside the factory. And we keep the factory flexible too. So we don't have a strict production line. We make all of our own rigs. We invest in good machines that are flexible. So when we want to change something, there isn't a huge investment to make that change. We do it because it's the best thing to do, and it brings cost value for everybody.
Right, and I suppose that my other question is linked to that was how do mortgage companies react to the kind of innovative construction methods, and also looking at the foundations, it looks like it's sat on screw piles, and I just wondered how I'm a passive house designer, and I wondered how we're struggling with how mortgage companies will provide a mortgage on houses that aren't just masonry on strip foundations. I just wondered whether you'd had any issues with that.
The simple route through that is to ensure that we have a Council of Mortgage Lenders approved warranty provider on board, and so we've been working closely with Checkmate for a number of years now, and Checkmate are providing a type approval of the system, which is what the mortgage companies expect to see to provide them with the comfort they need to lend. So it's a type approved system from a CML approved warranty provider.
We are also going through Agreement certification as we speak as well. Yeah. So we'll have that too, kind of belt and braces, I suppose.
Right. Okay, thanks.
Great, thank you, Liam. Next up is Neil Stevens.
Hi. again, yeah, great presentation. There's a lot of work, hard work going in there. It's good to see it coming into fruition. I suppose the everyone sort of anticipating this demonstration house is when is it going to be built? When's it going to be ready to sort of for us to view and see and touch and feel?
Yeah, so we started last week, started last Monday on that one. We're expecting a 3 to 4 month build time on that. It will come down a lot, but as you can imagine, the first time we do things, the end goal isn't to have a house sat there. The end goal is to learn how to do the next one better. So we will be putting it up, we will be taking it down. Parts of it we'll be building more than once because we will find a better way of doing it. And like we touched on earlier, the quality of the finish is what's the most important part for us. We're not going to rush a house through to say we've built the first one. We're going to build a house steadily, so when we get to that end point, we know how to the best method of building a house at this point, because it will change going forward past this as well. So 4 months isn't your build time for a standard house, but that's what we're expecting for the demo, so we can have a play.
Play.
Fantastic. Thanks, Neil. Okay, next question is from Rachel Heng.
Oh, hi there. Can you hear me okay?
Yes.
Yeah.
Yep.
Hi. Yeah, my question is basically, I don't know if this has been mentioned because I only joined in a little bit later after this started. Is basically how well are the materials and cassettes protected during storage, delivery and on site from rain and damp and any potential mold development?
Yeah, so when it sort of leads on from the question about the mortgage companies. So the way we get the mortgage companies on board is you have a strict factory control procedure. It means that we've actually gone further down the supply chain ourselves. One of the big things with timber is moisture content. So we have to have the moisture content in the timber from the moment we get it through the processing to the moment it arrives on site. It's not as easy as you'd first imagine, but we've developed the factory, so we're going to have air pumps that keep the air inside the factory at a constant humidity. When it goes to site, we've developed a covering system, so a nice Velcro covering system that when you load it onto the back of the trucks, which have got their own stillages as well. So we design the stillages for the wagons, which give you efficiencies in your delivery. So again, that's another cost saving, but it means that you can protect them well enough with the covers on to keep the moisture content consistent through transport as well. We've gone for the Velcro method just because we want to keep that cover on until the building's finished pretty much. When you put you can un-Velcro it a little bit, put your next wall cassette up, and then when you're ready to lift it all off, it all comes off together. So it's protected until that moment when your house is put together. And then they can go back through and get recycled on your next one.
With zero plastics.
With zero plastics.
Yeah.
Well, that's really great. Yeah, because I'm basically sensitized to mold because of my own history of the property I have lived in the past. So I'm kind of like looking at options to whether one is to actually build from scratch a property that can be possibly mold free for me, or retrofit from existing properties. I'm just kind of weighing up the pros and cons, but that's really good to hear.
Passive house will be amazing for that. Whatever you go for, passive house will be amazing for that.
I think the continuous ventilation that passive house must have will ensure really optimal air quality, which is it's very, very widely known to be extremely helpful for people who are sensitive to, well, there is no mold to begin with, but people who require, for health reasons, high quality indoor air quality, it's a significant thing. So you should look more closely at passive house.
Yeah. Okay. Thank you.
Thanks.
Thank you, Rachel. All right, next is David Breheny.
Oh, hi. Yeah, I'm quantitative. Got my own practice, and I noticed on the website you did have some costs previously, because I've looked at your system, but I couldn't find them again. So I just wondered if you're going to be updating the cost per square meter. And obviously it changes probably for the types and economies of scale. I'm looking sort of what sort of cost for one, and then obviously if you did 5 of the same, what sort of effect that has on the economies of scale. That was mainly it. And I know on the cost that you had previously, I think you had like a fixed cost element, and then obviously statutory authorities and grounds and stuff was, groundworks was sort of obviously variable or by others. So that's essentially my question.
Yeah, the fixed cost element is based on a square meter rate assumption. It's above mid-range in terms of price point for an individual house. It's entirely the cost for a notional house. We would simply say it's going to be above mid-range in terms of price point. Now, the finishes, the location, the geometry, the spec. There's so many variables, as you will know. There are definitely economies of scale for multiples, even more than one. So if it's a development of 5, there will be a reduction in factory overheads and economies of scale for materials and so on, which we would pass on to you. So I'd be very happy to talk to you about that if you want to get in touch afterwards.
Yes, I can certainly send you an email or speak on the phone. Yeah. Great, thanks.
Excellent, thank you, David. So we do still have a couple more questions, and we'll take those at the top of the hour. But we want to now kind of close up this hour, recognizing that some of you in the audience will need to move on to the next things in your lives. So with that, I'll hand it off to Ben, Hugh, and Mike.
Yeah, I want to say the KISS project looks fantastic. You're doing so many things right. And I just want to jump back a little bit to what Hugh was saying earlier, this point where you've got to ship it. So please don't run out of runway. That's all I'm going to say. Good luck.
Thank you.
Hugh, are you there?
I've double muted myself, Ben. I think so. Should be. Oh, good. So yeah, huge thanks to Max, Carli, Richard, and Mike for sharing so much today. Nice add on there that I hadn't noticed, the delivery in plastics. That's a nice touch, and it's needs to happen a lot more. So yeah, there's a lot of modular things changing, and everyone's covering them in plastic, so that's nice. But I suppose separately, kind of as it's the last episode, I wanted to thank not just you, but all of the people who joined us throughout the series and really shared so much. The impact to I suppose the open sharing of information from the Passive House general network worldwide is, I suppose it can't be underestimated. So yeah, thanks to everyone. You're kind of giving trade secrets, but influencing worldwide. So it's huge. So thanks to everyone. I also wanted to give a big thanks to Ben and Mike for agreeing to do this without any information at the start. So maybe apologies for that as well, but thanks so much, guys. Been a pleasure working with you and getting to know you a bit as well. The same to Zach and the team at the Passive House Accelerator, to Kim and Michael. I think we've grown a nice audience here and gotten some nice projects and content that people can use again afterwards and hopefully learn from. And I suppose lastly to Ulia for the enormous amount of work that she's put in and kind of made this series what it is as well. So yeah, least visible, but probably hardest working of the group, I would say. So thanks, Ulia. So yeah, Mike, over to you.
Yeah, just I'll keep it brief, Hugh. Thank you to you, Hugh, and to Ulia, in particular for bringing this opportunity our way back in whenever it was last year. It's been great, really worthwhile. I hope there's another run of it. I'd love to be part of it if there is. And Zach and Kim and everyone at your side, it's great to get to know you, to broaden our network in terms of Passive House and to support you in what you're doing. It's exciting, it's all good stuff. And thank you to everyone's here today listening. and asking questions.
So I think that closes our first hour. I guess we're a couple of minutes over, but we're pretty close to the on time here. And now we're going to just go into any remaining questions that we need to address. So Patricia Partridge, I think, is next up, and she asked me to ask this question of you guys, and that is, what is the aqua colored material in the base?
Was that? Is it the? Can you just confirm? Is it the big block at the bottom?
The animation.
Or one of the component?
I think it was from the animation. Yeah.
But
I don't know.
No, I think it is from the animation. The big block is just to represent soil. It's just how I model stuff that is sort of indicative in the environment. It's not part of the detail of the model. It's just context. Sorry.
No, that's good. Thank you. So next up is Aaron Gould. If Aaron is still here, it looks like Aaron's still here. Great.
Yes, hello. Thank you very much. Excellent work, and thank you for sharing. I was curious about the moisture management, the bulk water management strategy for long-term durability, especially the joint strategy on the exterior, and how you're evaluating that for long-term water holdout.
I'll take it.
Are you talking about external water or internal vapor?
Yeah, actually both, I suppose, but because that's going to vary from climate to climate. But primarily, how are you making sure that the building is staying dry and remaining dry, keeping the water out, and then of course just the moisture vapor management after you're protecting it from bulk water. So for example, the window interface is a very complex and risky area where water tends to creep in over time as tape and sealants deteriorate. So I'm just curious how you're evaluating that and what your strategies are at the joints and interfaces.
Yeah, well, the only proof will be in the pudding, of course, but the design intent is to use in terms of internal vapor control, the liquid membrane, which is a combination of factory applied in the large areas and then joints hand applied on site, which will be visually inspected. And externally, it's quality materials and careful attention to detail and checking is the only way anyone can do it, really. We are using the best materials that we can to manage moisture, whether it's internal or external, and we just have to make sure we've got rigorous quality control procedures when it comes down to the installation, because that's where it will fail, is on the install. It's not on the materials used.
Yeah, the materials we're using, like Mike said, at the top end with the longer lifespans. The hardest thing to manage is your install on site. We're doing that same way we're managing the factory control procedure and through the design. You can only install it in a certain way, and I don't know if you've heard of something called it's a Japanese method called poka-yoke, where if something doesn't look right, it's not right. So if you're putting a wall panel together and it looks different to every other wall panel, you've made something wrong or you've put it in wrong. So visually it checks itself. As long as you go through that step-by-step process, then you're going to be fine. If not, then your install teams have done something wrong, but that should be blindingly obvious as you put it together.
And will always be checked.
Yes.
Yeah.
Great, fantastic. Thanks, Aaron. So next up is Ian.
Sorry, I couldn't find the unmute button. Yeah, just curious on the joint compound you mentioned, if that's a commercially available product or if it's something that you've developed as part of your project.
I'll answer that in a second, but I'll just come back to Aaron's previous point. it is our intention to install in-wall moisture monitors as well to gather data, real data over time as well. I should have said that. So we need to rigorously monitor these buildings, so that will include the in-wall moisture levels as well. Ian, there are multiple companies selling similar compounds at the moment. So these are commercially available products. In fact, Hue sells one. The purple one happens to be purple because the company that sells it calls it passive purple. But there are others are available. It's nothing to do with us. We just decided to use it.
And then a similar question on your floor cassettes. Are you sitting on a wrap? Are you doing anything to the soil, or just by virtue of those the screws?
Yeah, so the screw piles are necessary to take the point loads from the structure, from the columns. There will need to be site-specific analysis of the soil in each case to look at foundation design on a more contextual basis. Our ground floor system is able to bear on the compacted hardcore in the best case site, but we'll still have to have localized piles to take point loads.
And then is there a wrap involved, or is the cassette sort of weatherized?
Did you say wrap or raft?
Well, like a Stego wrap or something that you stop the moisture or whatever coming through.
Oh, I see. So it's lined externally with impermeable material. So it is airtight and watertight. As a cassette, as a system, it is airtight and watertight.
And it's sitting flat on whatever materials on the floor.
Yeah.
No gap. Okay. Thank you.
Yeah.
Thank you, Ian. Next up is Stuart Loxley. And then I think that might be our last question. So if I missed anybody, or if you still have a question that you want to ask, now's the time to post it in chat. But Stuart, please take it away. All right, Stuart, I see you there, but I'll assume that I should ask the question on your behalf. So the question was, would love to know what heating system is used in the KISS houses.
Okay, so we have a low temperature wet heating system. The heat is generated by a heat pump. It's the best we can do for now. This space is improving and changing all the time. So we're going for a heat pump and low temperature wet heating.
Fantastic. Well, I think that closes the questions here. So again, thank you everybody so much for this episode, and what a wonderful way to wrap up what we'll call the first season of BPI. Are there any final words that folks would like to share before we finish up? All right. Well, congratulations, KISS House, and we're all so excited to see this develop and grow. So thank you very much for your inspiring work. Thanks again, everybody. Have a wonderful Thursday, and we'll be in touch soon. Be well.
Thanks very much.
Thank you.
Thank you all.